I'd like to welcome each of you back to our Math Methods class. This time we're going to finally see some payoff in terms of all the time we've invested in developing a sense of numeracy and a deeper understanding of bases, particularly base 10. When taken together, these understandings will help us get a better sense of what number actually refers to, and so it will be able to make it possible for us to act upon number and understand what we're doing. When we think about what it means to act upon number, there are certain operations that naturally come to mind. We can compare, we can add, we can subtract, we can multiply, and we can divide. And unless we understand what number is, these operations are fairly meaningless, and we run the risk of being like Pa and Ma Kettle, where we might memorize a process or a procedure, but not be able to use it in any sense of problem solving whatsoever. Now, we've made quite a bit in terms of using subitizing and chunking to develop this notion of numeracy. So I kind of want to tie a few things together and remind us that once we are numerate, there is another operation actually we should be able to do with number that has to do with counting. So this is our plan for this immediate little video here, is to re-mention a few things about subitizing and chunking by way of review, and to show how we need to lead from this into counting very carefully so that our students will be able to make sense of this first, most basic operation on number, and that's how do we go about counting something. So having said that, let's just review a little bit of what we know about subitizing and chunking. When we used subitizing and chunking, it allows visual representations of number to be easily developed. And in particular, it gives us the ability to see 3 or less up to 3 times. So when we put the two of these together, what it enables us to do is to easily represent numbers from 0 to 9 using objects. So this is what our 1 would look like. Remember, here's 2, 3, 4. You notice again, we go left to right, top to bottom, and this is to tie back into other tasks students will have to do, such as writing and reading. And so we have this beautiful way of representing now numbers from 0 to 9. I've used the units cube here, at least a sketch of it, to show this. And we also showed how it could be done using the base 10 blocks, using the tens, the hundreds, and so on. So what we find is that for each place value, whether it's a 1, a 10, or 100, we only have to be able to visualize from 0 to 9, and subitizing and chunking lets us do this. This means that it's going to be possible for us to represent at least any number in each place value based on 0 to 9, subitizing and chunking, and then we are able to make sense of larger numbers thanks to what we've learned about bases and the relative size of things as we get larger and we get smaller. So there's a method behind all of this time we've spent to really come to a deeper understanding of number. When we're dealing with numerical fluency, this is basically what it is that we're talking about. We're talking about the ability to go fluently between the spoken number, the written Arabic number, and the object we're using to represent that number. This should look quite familiar to you because it was the subject of several of our videos on building number representation. In fact, this is a way that we remember it quite often. There's our objects. There's the spoken word for 4, and there's the symbol we're using to represent the 4. You can find this under course contents, under handouts, under numerical fluency if you haven't found it yet. So now we're really fortunate in the subitizing and chunking are what I call a freebie. And what I mean by that is they don't require extensive instruction. There are some pre-counting skills, however, that do require instruction. And so before we get into operations on number, I wanted to make sure we at least mention these in passing. Van de Waal, of course, describes them as well. So you may want to go back and refresh your memory of this in the text. We talk about sequencing, matching, and patterning, and these do require instruction. So when we're thinking of sequencing at the pre-numeration level, it doesn't have to be overly elaborate or intricate. Fortunately, children have things that occur in their lives that follow a natural timeline, where some occur before and others occur after events. And so one of the activities that I've always liked to do is to have, say, 4 pictures like these on this slide, and the children are tasked to put this in the correct order. So let's take a look. Let's see if we can figure our way through this. Well, what would have to come first? Well, the first thing that would have to happen would be the baker would have to mix up the dough. The second thing that would have to happen is that we'd have to roll the dough out. The third thing that would have to happen is that we would cut out the cookies. And the fourth thing that would have to happen is that we would put the cookies on a plate and have them ready to eat. So this would be our first task. This is our second. This is our third. And this is our fourth and our last. And an important part of this is to develop the language and the vocabulary that goes along with sequencing. Terms such as first, second, third, fourth. These are what are referred to as ordinal numbers. In other words, what is the order something occurs in? That's a major use for number is ordinal as opposed to cardinal, where cardinal is how many of something do we have. In this particular example, we could say that we have a cardinal number of 4 slides. One possible order that we described would be to go first, second, third, fourth. That would be the order or the ordinal value. So this particular slide would be first, second. This would be second in our ordinal sequence. In terms of developing vocabulary, we want to make sure that we also talk about before and after. This gives us a chance of describing greater than, less than relationships, particularly when we're talking about cardinal number values. To help keep these two separate, when I think of cardinality or the how many, I think of cardinals sitting on a fence post and I'm curious about how many of them there are, all right? Ordinality is fairly easy for me to remember. I just think of the order in terms of which came first, which came second, and so on. The other thing that I find really helpful is to create personally meaningful sequences. So for example, here are 4 slides from Winnie the Pooh where these could occur in almost any order whatsoever. So it can be fun for kids to make up their own stories that you can share then, where they take, starting off with any one of these, and they can put them together however they'd like. A lot of creativity that can take place at this point. The thing that's nice about it is that when they describe their story to you, they will have a chance to explore and defend what came first, what came next, what came last, which came before the slide we were on, what's going to come after the slide we're coming on. Again, this vocabulary is extremely important that we develop. So we want to make sure that we have the opportunity to develop this as part of sequences. You'll notice that the key here is personally meaningful sequences. In this slide, there is really only one correct way of putting these in order. Here, almost any order you'd care to put them in can be justified through appropriate creativity. In your licensing exams, be sure that you keep track of these. So if you see a question like, Ms. Jones is getting ready to teach ordinality, what would be a good activity? you want to make sure that the activity you select is one that deals with generating first, second, third, what order something occurs in a sequence. Now, the other task that has to be presented is that of matching. And when we deal with a matching task, typically I like to have them match with a different manipulative, because it's not the manipulative that's being matched, but the number of items. So let's take a look at what we have here. Here we have the teddy bears that are being matched with the soccer balls. You notice that we're not matching the same type of item. Rather, the object we're acting upon is of a different type, but the number of objects is the same. What we want to reinforce in this case is that there's this one-to-one correspondence between teddy bear and soccer ball, sorry. This is important in developing matching skills that are transferable beyond just a single object, and that's going to be quite important. We deal with patterning. Patterning in many ways is almost a precursor to extensive development of bases. So we take something as the base we're acting on, maybe teddy bear soccer ball. That's going to be our base. And acting upon that object, we can use that as a building block by repeating the base. So you see here we have teddy bear soccer ball, teddy bear soccer ball, teddy bear soccer ball, teddy bear soccer ball. The astute observer here would notice this could be used to develop base 2, couldn't it? Because we have 2 items that are comprising the base. A lot of ways of going there that patterning will help us get to. The final skill, in order to be fully numerate, has to do with one-to-one correspondence. And just as you might expect, this means that each object has only one object number name associated with it, and each number name has only one object associated with it. So let's take a look and see what can happen if we do not have one-to-one correspondence. What you might have is you might have a group of objects, in this case the sons, and the children could give you the correct answer, saying there are 6 of them, without ever having counted. Let's see how that's possible. As we look at the first 3 sons, it's entirely possible for the child to use subitizing and just recognize that that's this many, that's 3. And so they could say, okay, that's 3. They could recognize that there are 2 in the next subtizable group and then 1 at the end. So they've never really counted. They just know we have this many, we have this many, and we have this many. And they know what that looks like. You just say the number names until you use them all up. 1, 2, 3, 4, 5, 6. As an aside, it's not uncommon for kindergarteners to come into school and be viewed as geniuses because they can count to 100. And in most cases, what they're doing is they're not really counting so much as they're just reciting magic words. 1, 2, 3, 4, 5, in some sequence that they've memorized without really understanding it. In order to understand, we have to have this notion of one-to-one correspondence. And when we look at one-to-one correspondence, this is what you'd like to see. You'd like to see that you have the number 1 attached to the ordinal value of the first son going from left to right. The number 2 would be attached ordinally to the second in the sequence, 3 to the third, and so on. So when we count from left to right, we'd be counting 1, 2, 3, 4, 5, 6. You notice again this left to right, 1, 2, 3, 4, 5, 6. Now, I'm going to take just a moment here to explore something about ordinality and cardinality with you. If we count consistently from left to right, you'll notice that there's only one ordinal value, 1, 2, 3, 4, 5, 6. So if I asked you to identify the 5th son, it would be this one right here. When we talk cardinality, order is not a factor. And so we can say, well, how many are there? That's a perfectly good cardinal task. How many are there? And if we count them in an ordinal fashion, we'll come up with a correct answer that's 6. But that's not the only way we can get there. For example, we could go 1, 2, 3, 4, 5, 6. And you notice that we're counting in all kinds of different orders here. We could even say, well, there's 2 here, and this makes 4, and there's 5 and 6, because we can subtize those together. So again, here's some thoughts on just basic number representation. Remember, base 10 is only one way of representing numbers, and whatever object you happen to use can work. You know, I'm a big fan of our song. And the power of number is that this idea can be applied to any object type. This is why when we matched, we didn't match teddy bear, we matched teddy bear to a different class of objects to focus on number rather than the object that we are trying to find the number of for a specific case. This is a lot of background information, but what it should help you do is to identify what it is to be fully numerate. To be fully numerate, we have to be able to visualize from 0 to 9 objects. Thank goodness for subtizing and chunking. That'll give it to us for free. We have to be able to recognize each of our place values and how large each place value is relative to the other place values. That's where your exploration with the powers of 10 is coming into play. We also have to have these counting skills in place. In particular, we have to be able to count with one-to-one correspondence. We have to recognize that whether we're counting teddy bears or soccer balls, this many represents this many. And it doesn't matter what object we attach that 3 to, but we want to make sure that that is the number rather than the object that's getting the meaning. This kind of pulls everything together for us. We now have our basics of numerical fluency. We have subitizing and chunking to build that visualization skill. We have our powers of 10. All that's left for us to explore now are the operations upon numbers themselves. And in doing so, we will start with a few basic questions.